I'm Ahmad Nassri. I'm CTO at Socket. Socket is a developer-first supply chain security provider. We look at everything that happens in your developer ecosystems and help you protect against supply chain attacks.
Love it. Ahmed, nice to meet you.
Nice to meet you.
So you have a unique angle on security, one that is near and dear to me as a developer. Tell me a little bit about Socket and how you're helping developers stay secure.
Yeah, so Socket actually started by our founder, Firas, who's a prolific open source maintainer. I think he has over 2 billion downloads of packages he created over the years. And kind of he saw the problem firsthand from a developer lens, like as a contributor, as a developer. And what historically a lot of these open source security scanning tools, they kind of rely on the CVE database that everybody has access to. All you do is just match what's in your production code into what's in the CVEs and then identify if something is bad, which just clearly isn't sufficient enough. And Socket started mainly as a mission to kind of do a zero-day protection against what might be problematic before it becomes problematic, before it's declared a CVE. Because for those who don't know, like something to get declared a CVE, there's like a holdout period, there's, back and forth that happens, discussions, debates, whether this is really a security issue or not. And then eventually when it does become a CVE, that whole process might take a month or two.
Yes.
Might already be in your production environment, might already be in your code base on your devices and so on. So you don't want to wait for something before you declare it a risk to your business.
Yeah.
And not all CVEs are treated equal. Like obviously there's a lot of malicious malware type of attacks that happen in the ecosystems, but there's also like obviously SQL injection problems and those type of things, right? Depending on the companies and the businesses that we work with, like especially in the financial institutions, like they need to have a zero vulnerability policies, especially if they're dealing with healthcare data and those type of things. So it's not less about kind of like what's actually good or bad or what's actually relevant. It's more about we need to be protected as a business, as a product. And that's what Socket helps provide that early detection before something is even known to the public or even discussed in a public sense. And we actually piloted like the malware category in the space before anybody else did, because again, CVEs didn't necessarily get into that level of detection. And we know, especially from things like NPM, where the post-install process or bundled packages or bundled dependencies are installed in there. There's potentially malware being installed as well. So Socket was the first to do that. We also started with the typosquatting attack, and nowadays with the AI, slop squatting. Which is another term we kind of coined.
What's slop squatting?
Well, slop squatting is when you like are using an AI agent to do like code generation or feature improvements on your code base, and it might suggest installing a package or using a package. Attackers and malicious actors are now using these kind of like hallucinated names to create fake packages.
No way.
So that when your AI might actually use it and install it, you're now vulnerable.
That's wild.
That's right. Like automating the typosquatting at a degree that we haven't seen before.
Yeah. Oh, I hate knowing that this is happening, actually. Like every time I talk with people who do security, it's like I learned something new, like this new vector that I never even thought about before. And I'm like, oh man, like you just have to be so vigilant these days.
That's right.
I'm curious, what are some other, this is fascinating. What are some other areas where you've seen AI just accelerate new vectors for attacks?
Well, I mean, just as we see the acceleration in like developer productivity, malicious attackers are also being very productive, let's put it that way. And they're able to iterate on things and do things at a much faster pace. We've seen in the last couple of months a number of attacks that happened at a mass scale, like the first ever worm on an open registry on NPM that happened, right?
Wild.
We've seen all the phishing attempts that were kind of like a doorway to getting into popular packages, and then from there trying to attack and getting into like, in some cases do like crypto kind of stealing, but in other cases trying to do something harmful and like stealing your source code, stealing your secrets, stealing your environment kind of context. And those things are happening at a rapid pace. Like we saw, for example, with one of the recent attacks, like the iterations in which that attack started to morph as it was started to being blocked and detected by ourselves and others. That's abnormal and new. Because typically it would be, okay, an attack happened and then, companies detected it and started blocking it. It might take a few days before they attempt another angle at it or do some other activity. But this is all happening in the span of 24 hours. They block on this side, they open up on that side, they find one vector that's relative or different to another one, and they're just moving fast. And a lot of that is obviously accelerated through AI.
Yeah. Now, We've seen a lot of open source make its way into our development environments as well. I'm curious, are there vectors there that are getting taken advantage of, like even in our IDEs?
I mean, yeah, actually we just published a number of stories about like IDE extensions that are either including malicious dependencies unaware by the author of the extension, or the extension itself is malicious by design. And that's another vector that we see today, where things like, your Chrome extensions, your IDE extensions, your MCP servers you're installing locally, your IDE tools and like CLIs that you're doing, like,
Yes.
Claude Code, Gemini Code, all that kind of stuff. These are things that people are running on their machine that are not typically looked at or scanned by, the standard old legacy way of doing things.
Yeah.
You're not going to put your VS Code extensions into a GitHub pipeline and run some scanner on it, right?
Yeah.
You're not, scanning your Chrome extensions or your local development CLI tools that you're doing. That stuff never makes it into a pipeline. Therefore, your AppSec teams and your IT teams don't have visibility into that. So how do you protect against that?
Yeah.
Socket has an answer for that.
So tell me a little bit about what Socket does to protect developers and applications in this way.
So a number of things. We obviously do the traditional kind of end-to-end supply chain, pipeline scanning as part of your GitHub, GitLab, and so on. And we do it obviously very well. We use AI internally for doing a lot of the detections of what's in the source code of a package. So we scan every version of every open source package that's ever published on any of the ecosystems, and then we compare it against what's coming up in your manifest files, in your Git report commits, or your PRs, and so on. But then outside of that context as well, we do Chrome extension scanning. So outside of the context of even the development team, like your company, what are your sales team and marketing teams installing on their Chrome, and is that stealing information or doing anything malicious? What are the IDE extensions, like we mentioned, like Cursor, Windsurf, VS Code, all that kind of stuff? What's running on the developer machine? Is it in itself malicious, like intentionally, or because those things are JavaScript packages at the end of the day, do they have something in their own supply chain that might be malicious that they are not aware of as a extension author? So we scan for those as well and help you kind of block them. We also try to protect the endpoint as a whole. So endpoint being like laptop devices and things like that. We have a firewall product. So the nice thing about the firewall product is whatever on the machine is trying to install anything, whether it's like a VS Code extension, trying to install things from NPM, or a developer doing NPM install, or your AI agent locally trying to do something, or even like, data scientists running something in Jupyter notebooks and installing things from PyPy, the firewall can detect and block all of that. So for us, the main mission, for me at least, is like I want to educate, prevent, and then remediate. Right. So if I can prevent something from happening first, that's kind of like the ultimate direction and the ultimate kind of solution. So the firewall product for us is one way to do that, to make sure nothing even gets to the developer before they even commit it to a repo, before an AppSec team has to even review it and deal with it.